Hello, this is Dr. Flight, and this is going to be a short little trip down associations among variables, correlation. That's what, when we want to show that variables have something in common with each other, then we often start with a correlation. And so that's where we're going to start here today. Now, when we start talking about correlations, we start to move into causal research where we want to start making some assumptions and some predictions, and we want to be a little bit more forceful in that we want to say, look, these two variables are related to each other, and one may cause another. And so that's a causal relationship. Now, correlation in and of itself does not prove causality. We got to be careful about that. Just because two things are correlated doesn't mean one causes the other. So there's some things we think of and we look at when we start to look specifically at correlation and causality. So there's going to be four things that we look at. And these go into hypothesis testing. And when we start to say one thing causes another, we look at these things to kind of say what's going on. And also, again, when we do a correlation, we're talking about a relationship between variables. We're saying that they move together. The data, it either goes up together or down together or inversely. So four things, though, that help us describe a relationship. First thing, presence. Okay, so especially when we talk about causation, when one variable moves and the other variable moves, they can't be related unless they're in the same presence, in the presence of each other. So when two things happen together, they're in the presence. So for instance, maybe we increased advertising spending and sales went up during the same period. So they both happened during the same period. They were in the same, they occurred at the same time, presence, that type of thing. So both have to exist in the presence of the other, I guess is the way to say it, to one, better understand the relationship between them, two, potentially suggest that these two things are causal in nature. Okay, strength. When we look at strength, what we're looking at is the strength of the relationship. So if two things are strongly related to each other, the metric that we estimate, so sometimes it's a beta if we're looking at a regression, or the coefficient of correlation, so the R maybe, if it's correlation. That measure, that thing that we're estimating, the bigger it is, the more important the relationship is, the stronger the relationship is. So strength is something we look at. Direction, it's another thing. So this is if one moves in one direction, does the other one also? So you either have positive or negatively related variables. When advertising goes up, sales go up. When price goes up, sales go down. They're inversely related. That's the direction of the relationship. That's what we mean. And finally, type. This is kind of a tricky one because sometimes we don't think of this kind of right offhand. We assume that variables go together maybe in a linear fashion, but they don't always. Sometimes they go in a curvilinear fashion. So if you can think of like a quadratic equation or some type of an equation where the two variables are not related in a linear sense, but in some type of a curve, if you were going to map them out or plot them in a space, you'd see that they were curved in relationship to each other as opposed to straight. That's what we're talking about when we talk about the type. We're really talking about the type and the manner in which they're related that way. Okay, so relationships. So this is kind of the beginning of how we start thinking about relationships. I know this is a kind of a talk about variation. When we talk about covariation, what we talk about is the degree of change that happens in two variables at the same time, and this change should be consistent and predictable. And that's one of the things that we're going to look at kind of as we go forward. Oops, sorry, there we go. Oftentimes we can do a scatter plot, and this will display this information for us visually, and then we can follow it up with some type of actual measure of correlation. Or measure the covariance by maybe correlation. That's one way we could do it. Okay, but I mentioned the scatter plot, and here's a scatter plot of two variables, x and y. We don't know what x and y are, but we can see that there's not like a pattern in the data. So this would suggest that these two variables are unrelated. A positive or a negative linear relationship might indicate themselves by being graphed in these ways. So on the left, we have a positive, that's the direction of this relationship. On the right, we have a negatively, two variables that are negatively related. If you see that the data is very narrow, like packed together, like in the line, but with a very narrow kind of width, then that'd show a very strong relationship to each other. That if they're really spread out but moving in the right direction, that would show a less strong relationship. And finally, we have a curvilinear relationship between two variables. And again, this is right. This happens where two variables are like this. Advertising effectiveness is like this, where at the beginning, when you put an ad out, people respond to it very positively up until a point. But then if you use the advertisement too much, people get burned out on it and the effects diminish. So in other words, when you first put the ad out, people are all excited about it. It's new to them. They respond. And then after a while, the ad just gets either old or boring or whatever. People don't respond to it very well. And so the reaction becomes negative, right? People stop buying, or they've already bought so they don't buy anymore, or they get to the point where they actually reject the brand because they don't like it anymore. Okay, so curvilinear relationships are there. Now, curvilinear relationships are not ones that we can do regression on. There's certain things we can't do with these. We have to identify what the relationship is, and then we have to fit a model to it. So like I said, it might be a quadratic model that we devise and that we estimate as a result of how the data type and how it's established. Okay, so correlation. We're not going to do a algebraic assessment of correlation. We're not going to derive it old school with looking at the differences from mean and stuff like that. We're going to let software do it for us. There's a whole lot less error, and it's a whole lot easier, and it's a whole lot faster, right? So let's let software and a computer calculate correlations for us. Now, there are lots of different ways correlation is calculated. There are lots of different calculations for what we call the correlation coefficient, or R. So that might be something to think about. Typically, though, we look at correlation between metric variables. Variables that are ratio or interval data. So take two variables, two, not one or not four or whatever, and two at a time. So we typically look at correlations that are two at a time. That's how we do it. Now you can do a correlation with ranked ordinal data. There is a way you can do that, so that's an option, but typically that's not what we're talking about. We're talking about two metric variables most often. The R that's revealed, or that emerges, will be typically, it can't be greater than 1 or negative 1. So, or less than negative 1. So it can't be greater than 1 or less than negative 1. It'll be between those two pieces. 1 means these two variables are perfectly correlated positively. Negative 1 means they're perfectly correlated negatively, so in the opposite direction. As those numbers in either direction approach zero, zero means there's no correlation at all. So if you get an R and it's close to zero, those two variables are not correlated. The further it is away from zero, either positive or negatively, it means the stronger the correlation, the stronger the R. Okay, so higher the correlation coefficient, the stronger the level of the association. Now, this goes in the negative direction too. So if it's close to -1, it's still very strongly correlated, but negatively so. It has an inverse relationship. Okay, so again, yeah, correlation can be either positive or negative for sure. Okay, there are certainly guidelines. A lot of correlation outcomes depend on the sample size. So if you have a really, really large sample, these might be like significant or something. But if you look at the actual number, so anything below, say, 2 or so tends to be very weakly related. 0.2 is what I mean, below 0.2. So plus or minus 0.2 or lower tends to be pretty weak. I see a lot of correlations that are, I don't know, 0.2, 0.3, 0.4 that are okay. Above that, it gets really good. So anything above 0.5, really strong, I think. I know there's a guideline here. And you can stick to this. I mean, I see very rarely, I see 0.8s or higher. But it happens. So anyways, you can kind of get a feel. Again, anything kind of in that below 2 range tends to be something that isn't particularly impressive. Okay, now let's switch gears a little bit. We can use software again. Excel. Excel is a fine software to calculate correlation if you want to. You use the equals Correl term, and then you put your range in Excel if you want to do correlations in Excel. It's really easy to do. SPSS, it's real easy to do as well. So in SPSS, we're going to click on the Analyze tab, Analyze, and then we're going to drop down to Correlate. And we're going to then have another drop-down box that goes, and we're going to choose bivariate, which means 2 variables. That's all it means, bivariate, 2 variables. So Analyze, then Correlate, and then bivariate. Okay, and we're going to put in a couple variables and then look at some output. I have a database, a data set. We've got 3 variables. One will be intention to buy, IB, intention to buy. A second one will be cost. So this might be the consumer's perceived cost of whatever the product is. And then the intention to buy is whether they'll buy it or not, the likelihood they'll buy. And then some attendance. So this term attendance is like if the person is attending to an ad, in other words, paying attention to. It's really what it means. Sometimes we call it attendance. So when somebody's paying attention, they're attendant. So that's why that word is there. It sounds weird, but it's not. It's not too weird. Anyways, so let's look at this. This is going to be, so you put that in the software, put those variables in, and you're going to get kicked out here a box. This is the data. This is what's returned. And there's going to be a couple things you're going to notice that are super important to remember. So don't forget these. When you see a correlation matrix, that's what you call this, the numbers in the top part where it says like 1.423, 0.020, those are the correlations. Those are the R's. And this is called a Pearson correlation, and that's not super important to know. You just need to know that this is R. This is the correlation between the 2 variables. Now you're going to see 2 diagonals. You're going to see the top diagonal and the bottom diagonal. And so the top diagonal, it's a reflection. So this is like an identity matrix where the bottom triangle of the matrix is the same as the top triangle. So you see 0.020 twice. You see it in the 2 corners. You also see 423 twice. You also see 044 twice. They're diagonals of each other. Okay. I think most people they're diagonal, so they look the same. They say the same thing, but for whatever reason, most researchers look at the bottom triangle. I mean, they use that. A lot of times we'll actually clear out the top We'll look at the bottom of the triangle. So that's one thing. So it's reflective. You've got two diagonal, the data repeated on triangles. That's one thing to remember. Number two, you'll always have ones in the diagonals. Okay, so, and because here, what's the correlation of the same variable? IB's correlation to IB is perfect. It's 1. Costs correlation to cost is 1. It's perfect. Okay, and attention variables, like their correlation, that it's 1 variable. It's not 2, it's 1. So it's going to be perfect correlation. So again, that's what you're going to see that in that diagonal. So what we really want to look at then will be the correlation between the variables. There's going to be 3 of them. And we can look and see how big they are and whether they're significant or not. So that's all we're looking at, size and significance, okay? All right, so that's kind of where we are. We're gonna look at this one here. And again, we set our significance level before we do our analysis. Usually it's 0.05. That's typically our cutoff. Again, that's a standard, 0.05. So the correlation between intention to buy and cost in this particular case is 423, 0.423. Remember, once you're getting up to that middle range and higher, you're in a good zone, and the significance level is 0. So it actually is something, but for a shortcut, they just put 0 because it's a super small number. And so it's well below 0.05. It's below our cutoff, so that's good. That means this is significant. The relationship between these two variables, it's positive, so I'm not sure how cost was measured, but it's positive. And so when one moves up, the other moves up. When one moves down, the other moves down. And it's strong. Relationship is strong. Yeah, we know that that's the case. Okay, other two are not significant. We have 0.02 and 0.04. Those are very small. R's, those R's are very small. The significance level is very high. These are well above 0.05. So clearly these two are non-significant. They're not significantly related in whatever way, right? It's just not there. Okay, so this is correlation. Correlations are the bedrock of regressions. Whenever I do research, I always do a correlation matrix first so that I understand what variables are related to each other. Once I do that, I can understand better how the rest of the analysis is typically going to go. It's kind of like a precursor. So I always run a correlation matrix first among my metric variables, and then I go from there. So, okay, so any questions you have, please let me know. Feel free to reach out. I'm so glad you had time to listen to this video, watch this video. Let me know if you have any questions. Thanks.